Hello, hello. Welcome to the Decoded channel where we decode the problems, such as the one that you see on your screen called Do Sum from Leetcode. Now, this is a very classic Leetcode style problem, and also this is one of the most frequently asked questions in technical interviews. So, let's see what the first is all about. The question says, given an array of integers and an integer target, written indices in this case, of two numbers such that they add up to the target value. We may assume that each input would have exactly one solution and we may not use the same element twice. Okay. And we can return the answer in any order possible. So there is no constraint on what sort of order the question is expecting us to answer in. This question has some constraints like what could be the length of nums, the range of I and target. So make sure that you check these out whenever you are trying to solve a DSA question, because sometimes, and actually mostly, these will be very crucial to decide what strategy are you going to pick up to solve your question. And also it includes that only one valid answer exists. That means we are most certain that at least one answer exists. um, and also we have a follow up on this question, that can we come up with an algorithm that is less than big of n square time complexity. We will see where do we reach with the solution and in how many ways we can solve. To just to give you a clue, we are going to solve this question in three ways. The namely, we have brute force, we will have a hash map solution, and a two pointer based solution. So stick around to see how each of the solutions fare against each other and what is the intuition behind all of the three solutions. Now, without ado, let's graphically analyze the question a little bit, what the question is asking and telling us. So, the question is saying that, hey, I am giving you a nums array. Okay. Now, this could be anything. For example, we take 2, 6, 5, 8, or 11, and let's say the target is 11, or okay, we already have 11, let's say 14. So target is 14 and this is our given array. Now the brute force, uh, how would you go ahead? Please pause for a moment and decide how would you go for a brute force solution. Okay, now for brute force we already know that, let's say if we start with two loops, the first one and the second one, we pick up the first value 2, then we add it up with 6, it adds up to 8. Now 8 is not equal to 14, then we match up 2 and 5, that is 7. Nope, didn't work out. 8 and 2, 10. Nope. And 11 and 2 in the end, and 13. So this is not our solution. We move on to 6 in the second iteration, and then 6 plus 5, uh, that is 11, and this way we move to each and every single element in the array. We add up and we try to see what the target value is, and we come up to the solution. So this is really easy to implement. We have two for loops starting with I. We go till the length of our nums array, and plus plus, we start the loop, we start another one, we start with 1, definitely because we want to start with the um, next value, because no point in adding up the current value with itself. Erase it up for cool. We start the second loop from j is 1, and this loop as well goes till nums dot length A plus plus. And what do we check here? Uh, we check if we check if I nums I plus nums of j equals to the target value, right? We check that. Uh, at this point, we would know if something is equal to our target. If it is, um, yeah, so this is going to be an if condition. So if this is equal to target value, then we say, now in this case the question is asking the indices. Sometimes it could ask you that, hey, is there a pair that sum up to this target? If that is the question, then we say yes. In this case, it is asking us for the indices. Then we create an array, an empty array in the beginning, and then we populate that with I and j, currently I and j, and then we return. So basically, for indices, we are going to return I and j. And if they ask that give us the values which sum up to the current target, then we give them, we return nums of I and nums of j. These are going to be our return statements, right? Now we are done with the brute force solution, but what is the big O complexity of this solution? And that is big O n square. Now you may ask why big O of n square? Because we are running this loop twice. We are running the loop twice through all the elements in the array. So we come up to the O n big O of n square. This is and for space complexity, we are not using any additional space, so that will be constant. This is our solution. Now definitely your interviewer is not going to be very impressed with this solution, even though this is a solution, but this is not the solution. The solution would differ based on the scenarios, requirements, and blah blah. Now let's say, um, let's look at approach number two. How are we going to approach this problem? Approach approach number two, right? Now we will use a um, very nice concept called hash maps, and we will try to show this same problem using hash maps. Now what is the intuition of this approach? Now let me write the array once more. So we have this array of 2, 6, 5, 8, and 11, right? And our target is 14. Now the intuition is, we take the differences. Now let's say we know that 14 minus 2 is 12, right? So 14 minus 2, then 16, sorry, 14 minus 6, and then 14 minus 5. What if I tell you that 14 minus 2, for example, that is 12? If I know that there is an element in this array which is 12 after 2, because we are at 2 currently, standing at number 2. If we know that there is an element such as 12, then we already know that 2 plus 12 is 14. So we have found our match, right? So this is a differences based intuition. Now stick with me. Uh, when we solve it using code, and when we code it out, we will understand it more clearly, what the intuition is. Now for dry run of this approach number 2, we will run it once more. Now let's say, because we are using hash map to solve this question, we obviously run a loop. So we are running it for from starting from 0 to the length of the nums, um, and then we are finding difference. Difference of what? Difference of our target minus our current value, right? In the loop. So we will have some I equal to 0, and then so the current value, that is nums of I. We will find the difference of this target value and nums, and then we will check if that difference value is available in our array. How do we do it? Uh, sorry, not in our array, but in our hash map. So we have, let's say, this hash map. Okay. Oh, sorry. We first of all find the difference, that is 14 minus 2, that would be 12. So we check and we ask the hash map that, hey, do you have 12, the value 12? And it says no. So we populate the current value into the hash map. So this is current value as well as the index, so that is 2 comma 0. Next is 6 here. What happens with 6? 14, it comes into the loop. We find the difference, that is 14 minus 6 is 8. We check in the hash map, is there a value called 8? No. So we store the 6 with its indices, that is 1. Next we move to 5. What happens here is it comes into the loop, goes to the difference. 14 minus 5 is 9. Looks into the hash map. Is there a value 9? No. Then we put 5 as well into the hash map with its index, that is 2. Same we do for the next element, right? In this case, it is 8. So 14 minus 8 is 6, right? Um, Now we ask the hash map, hey, do you have 6? Now, luckily, we have 6 here available with us. This is 6, and which is present at indices 1 here, right? So we already know now that, hey, 6 plus 8 would give us our solution in this current scenario. And because this question asked for the indices, then we would return indices of 6, that is 1, and the indices of the current value that we were differentiating it with, this I. So I is 8 here. I is 8, and its indices is 3. Index value is 3. So because the question said that order does not matter, the answer is 1 comma 3. All right. And what is the complexity of this solution now? This is really interesting because we are now using just one loop to solve this problem. Yeah. So for our approach number 2, the complexity for this solution using a hash map would be, let's find out quickly. We are only using one for loop. There's a difference calculation, and that's it, right? So our time complexity would be big of n. Impressive, right? Earlier we were having the time complexity of n square using the brute force approach, and using two for loops in that case. Um, so this is already a very big improvement right now. Now the space complexity, now because we are using a hash map, so our space complexity definitely is not going to stay same as in our first scenario, the first approach, where we were using nothing at all. In this case, the space complexity would be again of n because we are using hash map. So that was our approach number 2. Now we move to approach number 3. This is going to be a very specific approach depending on if it is required or not, and blah blah blah. And you will see why I say so. So this is approach number 3. And what do we use here? Now, how do we use two pointers and what is even two pointer, and how are we going to find solution to this problem using two pointers. So to give you a brief over what are two pointers basically, for any given array, because in this case we have this array of 2 6 5 8 and 11, right? You start here and here both, so basically you have two pointers. Now how are we going to use two pointers in this specific question? So first of all, we are going to sort the array. Now, as I said, this is going to be a very specific kind of approach. You won't be using in scenarios such as this approach. You won't be using in scenarios such as where the interviewer might ask you to give the indices, because once we sort the array, we lose the indices. Now, there are ways to retain the indices, such as we create a dictionary or a hash map again, of let's say 2 is at 0 indices, 6 at 1, 5 at 2. So we store the indices as well together with the value, and then we sort it out, sort the array, and then we process it, and in the end, whatever the solution is, whatever the answer is, the number, we uh, the corresponding index, we take that out, and then uh, we return that. So that would be a very short explanation to how we can use two pointer approach even when we have to return the indices. But in this case, I would not return the indices, but rather the numbers of what numbers, or when we add up which of the numbers inside of this array add up to the solution. All right. So let's sort the array real quick. In this case, 2, 5, 6, 8, and 11. Right. Now, to explain you the approach, how we are going to approach this problem using two pointers, we start here and we start here, right? And obviously, the target is 14. So, yeah, the two pointers now. Let's say one is named as start, the other one is end. So in this case, start is 2, right? And end is 11. We add them up. So we come, the addition is 13. Is it equal to our target? No, right? Now, what do we do? 13 is less than 14, and we know that our array is now sorted and it is in increasing order, right? But our 13 is less than 14. So what do we do? Which one of these pointers should we increment or decrement, right? So in this case, we move from left to right because we have increasing array. So now the next element would be 5 at index 1. So we add 5 and we keep 11 at its index same. That is 11 plus 5 would be 16. 16. Now 16 is more than 14. Now what we do? So we have exceeded the target value. So we move this pointer now from right to left, this side, and we stay 5 here. The pointer at 5 does not move. So in this case, we have now 5 plus we have moved to 8 here. So 5 plus 8, that is 13, right? So it is still one less than 14. It's not the solution. So what do we do? We move again from left side, right? So this pointer moves, the left pointer moves, the start pointer. So 6, and the end pointer stays same, that is 8, and 6 plus 8 is 14, right? And hence we have reached our solution, and this would be really easy to code it out as well. We have one for loop basically, or we can say in this case we can use while loop as well. So while start is less than end, and we see we add up the values basically. So the start and index, we will be initializing them somewhere in start, and I'm just giving you a pseudocode of how this would look like. So we initialize them, and okay, by the way, I made a mistake here. I initialized my variables with 00. How things can go wrong, uh, think about it and let me know in comments why 00 is wrong. But in this case, let's go ahead with 00. So this loop will continue. We check for, we basically add up s plus e, because we know it's sorted array. Somewhere we have sorted the array as well initially before the loop itself. So array 2 is sorted of array 1, right? So we add up start plus add and index, and if it is equal to our target, if it is equal to our target, then we return s and e. Else, if s plus e is, if s plus e is greater than target, then we move the start. If it is this, then we, because in this case s plus e greater than target, which was, I think, this case, right? This case here. And what did we do in this case? We incremented, no, it exceeded. So we have 16 here. So we have to decrement the end counter, the end pointer. So if s plus e is greater than t, then what do? We decrement our end. So end minus minus. Else, what do? We do a start plus plus. Right? So this approach is really nice, really straightforward. Um, but it comes up with its own complexities. Now, if we have to look at this entire solution and find out what is the complexity of this solution, let me know while I type out the complexity. So in this case, the time complexity would be, because we were sorting here, yeah, this place. So sorting would take us log n, and then the loop, while loop. So it would be n log n. So n log n would be our big of, n log n would be our time complexity. And space wise, we are actually not creating any other data structure, right? We are just using the same array. Okay, now this can be a little tricky depending on the context. We are not actually using the same array. We have sorted, and we have changed the array a bit. So even though I'm calling it O of 1, but depending on the scenario and depending on this on you can explain it could be O of n as well. So that's the solution here for the that for the problem of two sum. We use three approaches: the brute force approach, the two pointer approach, and uh, the hash map approach. Now let's code out quickly the hash map solution, which is the most intuitive according to me. And yeah. All right, now we move to code the solution for two sum using the hash maps. So we will create a dictionary, uh, because we want to return a dictionary, or let's say an array. So I want a dictionary of int and int. I would name it as dict. Initialize int. Yeah, and then we run the loop. Which loop? The outer loop. Actually, in this case, just one loop that we have. So we start with I, we run the loop till the length of the array, and then we keep on incrementing the value, right? Now what do we do here? As you remember, we calculate the difference first. So the difference is our target minus the current value that we have, right? And then if we find that our hash map contains if our hash map contains the difference, then we know that hey, you have found your answer, congratulations. So if this is the case, then we return actually yeah, we return the int array, the indices of difference and current indices. Now that is the answer. And in the else case where the difference is not found in the hash map, then what do? We add it. We add the current value. Terms of I is right. And if at this point we don't find any value, then we return null. Simple as that. Let's run the solution to see if we made any errors. Yep, we definitely made some errors. And in this case, yeah, so there was a small typo. Instead of contains key, we typed contents key. So these kind of things, they do happen. And now we see our solution is returning the correct indexes. Let's submit the solution and see if it passes all the test cases, and it does. Awesome. Cool. Then I will see you guys in the next video, and let me know what other solutions you want to see, and I'll see you next time. Have a nice day.